Questions number 9, 10, 11, 12, 13, 14, 15, and 16 from the Unit 6 Similarity Exam Review Geometry. Questions number 9 and 10, determine whether the two polygons are similar. If yes, write the similarity statement and scale factor. If no, write not possible. So question number 9, if they are similar, they should have congruent angles. We should see that we have 4 congruent angles in this polygon, and additionally their side lengths should be proportional, meaning all of their sides should reduce down to the same number. Do they? Yes, they do. They reduce down to 2 over 5, meaning that these two polygons are similar. Writing the similarity statement, we will simply go in the same order. Similarity statement, JKLM is similar to PQRS. Now for the scale factor, we're looking to see what we'll go from smallest to largest. So that's just the ratio. The ratio from the smallest to largest is 2 to 5. That is just our reduced down ratio of all the sides. 2 for the smaller polygon to 5, which is the larger polygon. Question number 10, we have a triangle. Same idea. We see that we have 3 congruent angles, so that means that their sides should be proportional. So 16 over 12 should reduce down to the same as 22 over 16.5 and 28 over 21. Do they? They do. They all reduce down to 4 over 3, meaning that triangle TUV is similar to triangle XYZ. TUV, XYZ. Now the scale factor is just going to be, we'll go from largest to smallest this time, just moving left to right, meaning that our scale factor is 4 to 3. Question 10 and 11, using the diagrams and the given information, find the value of x. Now in both of these, we are given a similarity statement to start with. So from a general sense, we know that since the triangles are similar, the angles are congruent, and more importantly, the sides are in proportion. So looking at question number 11, we know that all the sides are in proportion, meaning that side ST is in proportion to FE, TU, ED, SU, and FD. Now it's very important to note I'm using the similarity statement to help me know which sides match up with which sides. That is important because obviously these triangles have been maneuvered and turned, so that way we should not use our eyes to justify and say, oh, I think this matches up with this because it's both on the top. No, that is in fact incorrect. We are using the similarity statement to help us figure out the sides. So since I know all these sides are in proportion, I can set up a proportion between 2 of the 3 sides. In this case, we will use FE, ED, and TU and TF. So 126 over 27 equals 2x plus 5 over 30. Now it doesn't matter the order that I have them. I could have flip-flopped these. I could have had them flip-flopped up and down and side to side. Either be the same. So to solve a proportion, we know, meaning I take 6 times 30 and 27 times the quantity 27x plus 5. 126 times 30. And then solve a 2-step equation. Plus 135. 729x. So then we'll divide both sides by 729, giving us an answer of x is equal to 5. Question number 12, same idea. We are given 2 triangles are similar, meaning we know that the sides are proportional and the angles are congruent. So I should be able to set up a proportion between the side lengths. Note here that we have 2 overlapping triangles. So SG should be proportional to SR, first two letters, and SH should be proportional to ST, first and third, giving us the proportion SG over SR, 12 over 20. Notice this whole length is 20, 8 plus 12 gives us 20, is equal to SH over ST, 15 over 4x minus 7. Once again, we're going to cross product, giving us 12 times 4x minus 7 is equal to 20 times 15. We're going to distribute and multiply this out, giving us 48x minus 84 equals 300. We'll add 84, giving us 48x equals 384. Finally, divide both sides by 48, giving us an answer of x is equal to 8. I will note that on these problems, we're simply asked to find the value of x. We are simply asked to find the value of x. However, these problems could easily be turned into find a side length, where we have to take the value of x and substitute it in to find our missing side length. As an example on number 12, if we were asked to find ST, we would take the value of x is equal to 8 and substitute it into our expression 4x minus 7. 4x minus 7 with x equals 8 gives us a value of 25 for ST. That is obviously a next level question. Wasn't initially asked on the review. However, that's what could happen on the test. Taking a value we found and substituting it in, doing something more with it. All right. Question number 13 and 14. For what value of x makes the two triangles similar? So in this particular case, we don't know whether the triangles are similar yet. We need to actually show that they're similar by, in this case, we're using it by showing and finding the value of x that makes the sides proportional. So it is set up very similar to questions 11 and 12. However, we are coming from a fact that we don't know that they're similar, but we're hoping they're going to be. But in terms of solving the process, we are still going to set up a proportion between the sides using our similarity statement that we want to be true. So question number 13. We're going to go ahead and set up a proportion between the proportional sides, BC, BD, and BV and BU. BC over BD is equal to BV over BU. Note BD is the length of the full side, 8 plus 6 gives me 14. Length of BU is equal to the length of the full side, 2x minus 11 plus 12. So that reduces down to 2x plus 1. It simplifies down to 2x plus 1. That's a little different. Normally we're just adding numbers. Here we're adding numbers and an actual x as well. So we just simplify the expression 2x plus 1. Let's put this into the proportion. 8 over 14 over 2x plus 1. We now can go ahead and solve this proportion by cross product. 8 times 2x plus 1 is equal to 14 times 12. We're going to distribute this 8 and multiply this, giving us 16x plus 8 equals 168. We'll subtract 8 from both, giving us 16x equals 160. Divide both sides by 16, giving us a value of x is equal to 10. Question number 14, same idea. We see that we have a shared vertex, meaning we have vertical angles which are congruent. Now, in order to show these are in fact similar, we need to show that the sides are proportional. We'll set that up. UM and UW are proportional. That should equal UL over UV. UL over UV. Or 5 over 5x plus 5 is equal to 9 over 36. 5. Okay. That being said, we're going to go ahead and cross product, giving us 5 times 36 is equal to 5x plus 5 times 9. We're going to go ahead and distribute this 9 and multiply this out, giving us 180 equals 45x plus 45. Subtract 45 from both sides, giving us 135 equals 45x. We'll divide both sides by 45, giving us x is equal to 3. So those are the values that show that these two triangles are similar, the sides being proportional, that x value works. All right, last two questions using the diagrams and the given information, find the unknown lengths. Here we're given the proportion that we're supposed to use, and we're trying to go ahead and find a side length that shows up in our proportion. So we'll use our diagram to go ahead and find those unknown sides. In 15 here is side length BE. We're going to go ahead and plug in the values, substitute in the values that we know. Giving us 20 over 8 equals BE over 6. 20 over 8, BE over 6. We're going to go ahead and cross product this, giving us 20 times 6 is equal to 8 times BE. Both sides by 8, giving us BE equals 50. Question number 16, same idea. We're going to go ahead and solve for PS, which is this side length, which allows us to set up the proportion 24 over PS equals 28 over 21. We're going to go ahead and cross product this, giving us 24 times 21 is equal to 28 times PS. We're going to multiply this out. 504 equals 28 times PS. We'll divide both sides by 28, giving us 18 is equal to PS. Main theme of this entire page, setting up a proportion and using the cross product property to help us solve, all starting up with setting up proportions. Please remember, I would note one thing on this page is the idea of scale factor. touched on this briefly in the unit and something that you've covered before. I will be asking you for the scale factor on several problems. That's just the reduced down ratio. Here we're doing it from smallest to largest, 2 to 5, and here we went from largest to smallest, 4 to 3. Please note on that. Thanks.